the way they describe it is the encapsulation, hiding the data, protecting the data, but a slightly modified version I'll use to describe the encapsulation is transmissions. You can have an automatic transmission. It shifts for you versus a manual. The idea of the encapsulation is an automatic protects you from buggering up the inner workings. If you don't know how a manual transmission works, you have to shift the gears. And while you have more control, you can accelerate potentially faster in the long run, although the car shifts faster and you can actually do some tricks where you say you rev the engine higher so that you get greater speeds. But if you're not, the encapsulation protects you from doing something stupid that you can with an automatic that you can do with a manual, where if you have the engine running too high, too fast, then you can damage the engine, or potentially you can actually blow the engine. So if you're shifting too slowly, so it's almost like with a bicycle, you're on the sprocket and you're on the smaller sprocket and your wheels are pumping so crazy because it's a smaller instead of the bigger sprocket. It protects you from dumb things like that, the encapsulation. So more than just the interface here, he's described as an interface protecting you from here, a more specific one, the transmission. So the definition he uses for the encapsulation, at this point, he doesn't distinguish between two definitions. Here, essentially, it's information hiding. It's really called information rather than the data, more common, but data information, not quite the same. Okay, state is basically the value of variables at a period of time. And again, as I say, I could go through this quickly because if you don't know that class definition has this, well, this is 231 stuff, and you're setting it to be valid. That's a given, you might think. Why is he saying this? But when you actually have the interface to it, what I explicitly shown, he doesn't explicitly show it is, you can use the mutators, for instance, to prevent you from setting the attributes to invalid values if you have a certain range, for instance, or even references. Don't set a reference to null. Okay, so hide every, as a rule of thumb, yes. Okay, yeah. So he said variable. He's careful here. Everything that you can actually change as opposed to a constant. There was one exception in Java classes that it actually was public for a variable. Actually, they've changed the definition because I checked again over time. It was for the GUI classes. So here's one exception where they made it public for a very long period of time. When you have a GUI component on a screen, it has all the components, whether button, window, or something else, has an XY attribute to indicate where the screen is, X, Y. So if it's XY0, it'll be in top left. And if your resolution is 640 by 480, then X is 640, Y is 480. Fine. Initially, those ones were public. Now it's the newest API, it's private. I probably should have gotten a screenshot of that parent level class of all the GUI components just to prove that they actually made something public for a period of time. I'm not lying, I'm not hallucinating. My take on why they made it public is Java's existed for a very long time in the 90s. And Java, you don't need those for the quizzes, but my take on why it was public was Java initially, before the internet was the way the internet was, where the web was existed, before the web was so popular, Java is used a lot for web. Not as much now, but it really took off then, running Java programs. But before that, many decades, 3 decades ago, Java was meant to run programs on basically intelligent devices, precursor to smart devices. It didn't take off. 3 decades ago, or even 2 decades ago, the hardware on those devices wasn't so smart. It was a lot cruder, slower. Consequently, my take on why they made the GUI components public is if you have an accessor mutator and the hardware is so slow, having even just that method call could slow it down. And GUIs you want to run faster. Already you're drawing a graphical interface. Making that method call can slow things down. So that's my thought on why they actually made the exception and made those variable exploit attributes public. But now devices are so quick that there's no need to worry about that speed, at least in terms of just calling that method as a setter or getter. I don't know why he talks about this because even in his notes, he's talked about it again. It's not overly, and he also included that same table that I have. Not overly complex if you have a nice simple table. The only odd thing is the protected, why can you access it in other classes during the same package for most people? How to build a constructor. So yeah, this is 231 stuff. However, there's this point over here, this last point. Can you, because he sometimes he does test quiz right, at least in the early ones, quiz right on his notes. And at least in the early quiz, I noticed he's extremely specific. Anyone have a thought as to what he's getting at here? This is one of the points where I could see that you all could be a little bit hazy on what he's talking about. This point. It's in conjunction of constructors, keep that in mind. Okay, so what he's getting at is the constructor, you're passing information into it and you're setting attributes, that's the whole point of it, to those values. I had person, I had, say, age and name. Well, what he's considering is in certain circumstances, it may not be appropriate simply to pass all information and have a user of that class set that information. For instance, we could have, for instance, take class student. Each object is a student that tracks student information about one student. It has the usual things like the name, contact information. However, your student record also tracks grades. What should be done in a controlled fashion is, when he's getting at don't pass all information or control it very carefully, is you shouldn't allow easily the ability in that constructor to essentially specify the grades. Or an employee object where you can specify your salary. So be careful on what information you set. Think about the attributes. Maybe this information gets read in from a database from some other controlled source rather than from the program. So after you construct the object, you have the information about, say, the name and age. And then later on, then you'd actually, as the student starts taking courses and gets grades, that's where you'd set it, but not initially to the constructor. Anything, just think about that. Certain fields you might not want to set that way. Okay. What would you not do? Yeah, so this is a case where a student participated, the same student, and he used the car example in the first case for encapsulation, and then he happened to use driver's license again. A person who is applying for driver license doesn't get the picket, so you wouldn't have it, say, necessarily pass the constructor. You'd have it, I don't know how they generate driver's licenses, say that number, but they have some mechanism to prevent it from being unique and according to some certain format. But the guy came up these two examples. I said, did you look his notes ahead of time? And he swore up and down, no, he didn't. Interesting. Maybe they use it as an example in 231. So what else do we have? Oh, so what he's getting at over here. So he has that string. Just because something consists of some digits doesn't necessarily, as an example, not the only one, just because it consists of digits does not mean you should store that information with a numeric value, a numeric variable. Typically, you use a number to store, a primitive number to store information if you need to treat as number, perform calculations. On the other hand, there might be times, yes, each one of these, we have digits, but you're not going to perform calculations. Social insurance number, you're not going to do some calculation on it. So, and you might need to manipulate it as characters. So consider, should it perhaps be a string? That's what he's getting at over here. Formats about things. How do we represent the date is one that's contentious, not just, okay, what format, if it's numeric for, say, the month, order as well too. People argue, no, it's standard this way. And then other people argue to the red in the face, no, this is a standard. Yeah. Yeah, so I wasn't exaggerating when I said this section is extremely basic. You might not kind of ask yourself, if you're really doing a meta thinking, encapsulation, if I didn't give you the two definitions, if encapsulation is synonymous with, well, okay, this one's okay. Later on, get and set, so you have the public interfaces. The constructors, in of itself, you might not think that's information hiding. But the constructors is the second definition, ties in the second definition of encapsulation, defining the class. And finally, he has code for actually how to write these. Yeah, but if you don't know how to write these at this point, you're really in trouble. What else do we have here? Anything else? Different terminology. Yeah. Okay, so he gets back to the information hiding, but he doesn't actually say with the mutator one. This is, remember I said, every other textbook and every other prof that teaches OO and has accessor mutators, they actually do it this way. And you might think to yourself, well, this one's actually a hard example to really tell. But what is the advantage of set foo? We're passing an int. Int new foo, this foo. Oh, just this naming is a little bit strange. This seemed like it was an object. Okay, so we were setting an integer attribute. He didn't define the whole class. It got me confused for a second. But I had to look at this. So it's an integer attribute, presumably, and we set this. Usually foo is used in conjunction with objects. So this naming is a little bit, got me confused a bit. In any case, okay, it's an integer. And you think, well, what's the benefit of this over just making it public? It doesn't prevent you from setting it to, say, an invalid value. All the other sources, they basically do it this way, but they don't have the simple error prevention. If it's a percentage, only allow this dot foo to be set a value from 0 to 100. In that case, it provides more benefits than just setting it, making that public and let anybody set it to whatever values they want to. And what he's getting at over here is with the accessor methods, well, did he say accessor? Wait a minute. Get? Oh, yeah, it even says accessor. Well, Java itself only returns one value. So unless you're returning, say, an array that contains those 10 values, you can't return 10 values. So say don't get all 10 values, but you can't return 10 values. This part, however, your mutators should only change one attribute. That's what he's getting at. That makes a few different reasons why you want to do this, but one reason goes to good design of methods and functions. It completes one specific task. Maybe you want to set just one attribute as opposed to all 10. Well, why force 10 parameters to be passed in here? However, here's something that's new. No one in the first lecture knew this. I actually didn't know this, but that's because I haven't really fiddled with IntelliJ. Might save you some time. If your variable attributes are private, you should almost always have a accessor so you can see it on the outside. Maybe a mutator, it depends. With the methods, it can be tedious because if you have almost every attribute has two methods, retyping them can be tedious. Here's a shortcut where IntelliJ and other IDEs, I believe as well too, provide the auto generate for you. Something I didn't know, picked it up. Something for you, could save you a lot of time. Tedious grunt work. Okay, this is where I'm actually going to start getting into my own example here because I can see it being still a little bit on the hazy side, whether it's terminology or concept or both, because the first lecture they actually had, not all got it. Actually, I don't think anyone really stuck up their hand except for the one person or another person, that one person out of the bigger lecture. What he's getting at over here is line. These are references. References contain an address. So what we have here is two references pointing to the same object. And if you do this assignment directly, all you're doing is copying addresses. This is an example that I've cited a few times during the semester, but also I mentioned where it comes up, assignment 1, there's at least one person who I know of that had that problem. With assignment 1, you have an array and they wanted to create a copy of the array. So they precisely, if this is array 1, array 2, they did this and then they're baffled. Wait a minute, how come I only have one array? Because they start editing it thinking that it's two arrays. It's the same array that's being edited. And what we're getting at is copying from here to here, the address is different from copying the data from here to here. So you're making a duplicate of the data, but you have two separate objects. Each of these references points to a different object. So what you were supposed to do in assignment number 1, hopefully you all got it eventually, was if you needed a scratch array, you can use class arrays, and I forget the exact name. That's where the API is handy. Arrays copy, I think, and then you get a duplicate array for you. Terminology, deep versus shallow copy. Review the terms. These are actually common terms, and I introduced the terms, the encapsulation, information hiding, because you should know the terms after taking an OO course, but also they're standard terms. If you are having trouble with a concept, then you have a term where you can look it up, as opposed to, I don't know how to describe it in the search engine, won't be able to find it for you. So question for you all. This is some participation here. At least try this in your head if you're too shy to say something. What is a shallow copy? Describe that. Anyone want to be able to describe it? Let's start with the first one. Shallow copy. Or use an example. Nothing. A shallow copy, essentially, diagrammatically, is that, or this, code-wise. A shallow copy is when you have references or pointers, and essentially you just copy the address from one reference or pointer to another. Shallow. So, and oh no, he doesn't have that name here, but that is a standard name. See, it's one of the things that I rather like with the Adobe PDF reader. Okay, now that you know what a shallow copy is, anyone want to take a stab? What is a deep copy? And we have covered this one. Getting quieter and quieter. Well, if a shallow copy is a copying of addresses, a deep copy, diagrammatically showing this, is, oh, okay, so now we actually use that. That term shallow. Or what the pointers refer to. Just to illustrate, we have this example here. And so this is my example. So it is available on the web page, and there's that shortcut in D2L. I have class person with name and age. A constructor, we initialize the name and age according to parameters here. I don't have all the set and gets because you've seen plenty of them, but that's not the learning lesson. We have one for the age because that's the one I'm going to use to illustrate deep versus shallow. And then a toString method, so we can quickly see the string representation. This make copy, what we do, we see here is we create a person object. But with this person object, we call the constructor over here. This one calls. This one calls this constructor. And it copies the attributes here into that new object. Which is in essence a deep copy. And then it returns that. And then it returns the address of this one. So it's accessible now. So we get a copy of the object. We call this, well, if the driver here, I'll make copy in a little bit. Two references. Now we create a person object, name and age. I annotate this. The output, see, it's going to be a shallow copy. We're just going to copy addresses. Copy the address. We create the object, put the address of the object here. We copy this address from here to here. Now, that's why I have the set, so you can clearly distinguish these two. We might think that we have two objects, a P1, P2, and we're changing only one of the objects, a new one, set age. However, I have a toString implemented, so that's why I can do this. So now we display P1, P2. It's one object and not two, because they're pointing the same object. Over here now, we're about to do a deep copy, and this is where I call that make copy. We have a copy of, let's see, P1s, because we're calling P1s make copy. So a copy of the attribute whose copy method is called, that's why it's P1s. And now P2 contains the address of this object that we created here. Two separate objects. Now, I do the same thing that I tried to do here. I thought that they're two objects, but it's only one. So basically that one object's age got changed. Now, only the object referred to by P2 has the age changed. And we display it to prove that we have two objects. See, the data is different. Now this one's 73 because I set it to 73 here. But this one I changed 37, the P2. That's a deep copy. Any questions about that? So this is review, but it's one that students still have trouble with, and or the term is one that tends to stump people. So that's why I have an extra little example here. And unlike his, where he has diagrams, a code example, so you can actually, and the source code's available, see and edit, run it. Something new, a copy constructor. This is a new term. I didn't have time to go through this previously because it was such a rush, but copy constructor is actually a programming construct that is not uncommon. It is the actual term for this, and it's not Java specific. It's OO. Any OO language should be able to do it. Anyone heard the term? Okay. With this term, with this method, what we do is copy the attributes of the argument. So the argument, this is in class person. So we're creating a constructor here. This constructor takes as an argument another person object. So it copies the attributes of this person object here. That's what we're referring to here. And who does it copy it into? Well, this is a person constructor. So we're just about to create another, a second object. This is one object. This is a second object. And the second object, well, before we copy it, error prevent, just make sure that someone doesn't goof and pass something that's null here. Now we access the attributes of that one, and we put it into this new object that we're creating. So we create a new object, and basically the attributes are the same as another object. Oh, I should, just about out of time here. So this is a copy constructor. Any questions about it? Okay, back here, I almost forgot something. I put it in the documentation for this example. An alternative. Shoot. I actually wrote the code for a copy method for two reasons. One is so you could actually see it being done. Where the heck is it? Make copy right here. The other reason is this alternative is actually, well, it hides it. You're calling someone else's method, but it's a little bit more complicated than mine. But I'll make you aware of it. The clone method is kind of on the complex side in a few ways, but it comes with class object. It would make sense to put it there. And with this clone method, it basically does what this one does. You have to handle the exception handling as well too. And I believe you might need to implement, yeah, you do have to implement an interface, a clonable interface, which we haven't got to, which is another reason I actually gone through it because I didn't have time to go through interfaces. So I'm making aware that there is an alternative to doing this manually. Okay, so here he goes through again the application of heaps, the stack, and references. So what we have over here is the heap, and this is for allocated memory. Recall the heap is dynamic memory. So when we have the new keyword in Java, you can recognize something's being allocated on the heap. This, on the other hand, this is a variable, and with Java, what I had to think for a sec. With Java, you can think of all variables in some form, even if they're attributes of an object. So this one has attributes. The reference to that object is going to be a local somewhere because there's no globals. So these locals are going to be on the stack. So that's how the stack and the heap come into play. And then the references are basically contain the address of something on the heap. This will be a useful review because I'm going to go through something. Actually, I've got a quiz for today, participation quiz. I ran it in this morning's class and I did a bit of a review. So one of the questions I thought people would have trouble with, it relates to this and references. They did pretty well. That's good because it shows that they understand. It was a trace, understand what I was talking about. But there's another question. Well, we'll see how you guys do compared to them. It surprised me they didn't do quite as well. But in some cases, there's actually people ask me questions after class. They just completely misinterpreted the question. But if we have time, we'll get to it, if not Monday. But some of this we'll see the application of. It still wasn't perfect marks in these ones, but you can see how you do. Okay. But I was pleased actually they did better than, say, past classes. Perhaps it's because it's a filtered group where the ones who are showing up to class are really keen. But things with references, pointers, if you discuss with the undergraduate group, for instance, this is a way you can, I know you're busy now, but when you get a chance, about pointers, most of them will probably tell you that typical undergrads have trouble with pointers. And that's where the references come into play. Okay, so I'm not going to go through the detail of this one because most of it's a review, but it's an animation just showing how we allocate the local and then we allocate memory, the local reference, and then allocate memory on the heap for objects in this case. But it can also be allocated for things like arrays because array uses the new keyword. Okay, so the trace is fairly basic, just walking through a case where they're allocating different things on the heap and the stack. And this part, okay, now he's talking about, before he said something about, I think, access modifiers, and encapsulation ties into access modifiers. The one of the two definitions of encapsulation is, I'll use the other term, information hiding. So this is a violation of information hiding. So here's a question. Interesting. Oh, here, actually right here. How does this violate information hiding in this code? Anyone want to give take a stab at it? Again, try it, even if you don't do it publicly, try it on your own. Think about this. Nothing showing up. Okay. Here's a hint. Review of the information hiding. Variable attributes should be public, and the only way to access or modify them is through public methods. So attributes are private, and you can only access it through public methods. Now with that reminder, the hint, how does this violate encapsulation? His is actually a little bit more implicit. No, nothing? Interesting. Less participation. I would think people might participate more in this one because you get some anonymity versus the in-person one. But I think just one person stuck up their hand in this morning's class anyhow. So this part, How does this violate encapsulation? And it shows the consequences. Because this is the biggest hint right here. This is where the violation is. Anyone want to explain how that violates it? Still very quiet. Okay. Then I put over here explicitly, how does this violate it? It's a variable attribute. Even though it's immutable, you can still have name point to a different string. It's public. Because it's public, we can directly access it. There's a violation of encapsulation. So it is more implicit, but then I made a screen grab over here of the definition of class, which makes it more explicit. And the consequences of violating encapsulation is we can set the attributes of the class to invalid values. Any questions there? Okay. He calls it a privacy leak. I wouldn't really call it privacy. Privacy is typically when you're accessing information when you shouldn't. Here you're changing information. I'd say you're setting it to an invalid value or perhaps corrupting it. Different terminology here, but in case you ask why it's called privacy. Because you think about privacy in the real world, you're accessing privacy breach with say someone's hacked an account. The idea of the privacy breach is they saw information that they shouldn't see, as opposed to say someone hacked it and then modified it. Okay. Okay, he's about to get into something. So this is a review, but it doesn't hurt to have this review where you have these instances here that is variable because it's not final and it's not a primitive type. It's not an integer, for instance, but it's a reference to something. That adds an extra level of potential security issues over, say, an integer because, well, I won't say the because yet. So what we have here is, let me think for a sec. Oh, so it's just showing again, S is a reference to a series type, a series object, and it shows the allocation of the local S, and then the object over here. But the gist of this is, let's save some time. Okay, this is different from the previous one. Let me make a screen grab of the previous one and contrast this. Because you might not, this is a subtle side, so you might actually be missing, might not recall this. So this is violation of encapsulation over here. I'll keep it handy. And so this is the worst case, directly access attributes. This is essentially what you were doing with Python OO, quote OO. It was bad OO. Now, down here, see, we can't directly access the attribute like we do here, but we're using a mutator method. What's the issue over here? I wouldn't call it a data leak per se, but we're changing it when we shouldn't. That's the way I'd word it. Or perhaps changing it to something that's invalid. What's the problem over here? This one's a review, so it's nothing new. There's a bit of a hint. So I'm not throwing a trick question at you. Something that you haven't learned. Well, the set name, it has a reference to name, we can change it. No security in the mutator, essentially, my extra part. It's hard to tell if it's example because, like I say, most people, when they write the accessor mutators, they say you're not supposed to make this public, you have the accessor mutators. But what they don't do is they don't show any way of protecting it. So recall when I had my example, when I talked about accessor mutators with the inventory example, recall that one? I said, you're supposed to protect data. And I said, well, what if you didn't do this? I made everything public. And I was able to set the inventory beyond the bounds of 0 to 100. Those are valid ranges. But then when I created an accessor mutator as the inventory class, inside the mutator, I said only set the inventory if the new inventory value would be in the range 0 to 100. And inside his method, he does it, Professor Hudson does it the way most actually all the other textbooks and other profs do it. They say, okay, well, you have a mutator, but they don't do anything with it the way I did. So it's a little bit harder to see if this example. But with the previous example I showed, you can take advantage of having code here and trying to prevent that data variable, in this case, what is it? The name from being set to an invalid value here. He just doesn't show it in his code. And that's worth mentioning. It looks like, well, either guys are tired or scared to participate, but it might be a case where you're not participating because you've forgotten some of the concepts. So the review isn't a bad thing in this case. That's why I went a bit slower because I have a feeling it would be necessary. Okay. So what he's getting at right here, straight out, copy of reference versus copy of the object, unless someone wants to describe what he's talking about here. Actually, all have been pretty and being shy about participating. So essentially what he's talking about is a deep, whoops, right here, deep versus shallow copy. And using his terms in the heading there, the deep is copying the object's data, actually, not really to be specific, object's data. Shallow copy is copying the reference. And when you have reference, that copying isn't necessarily a bad thing when you're parameter passing, for instance. This anymore. And this is something that I got into previously. Even though you have accessor mutators and you can't directly access an attribute, if it's an attribute that is a reference to something, then that adds potentially another level of security problem. It's not security of someone hacking it, but essentially someone misusing your code. Even if you had no mutators and you just had a get, the buffer just in case. And we have a constructor that instantiates it. Now, if we have so this one, we can't directly access it outside the class, but whoops, get. And just to be clear, so I haven't defined a constructor yet. And there will be no mutator method for that attribute called SB. I just have an accessor. What he's getting at here is illustrated here. Where's the potential problem misuse? Or as he calls it, a privacy leak here. With just the code you see, there's enough code to be able to tell where there's a privacy leak. Or potential for misuse, use a better term. There it is. We return the address So if we had an instance of class A, I just name it something different. Don't have to. So I have a local and assume that this isn't a method here. A get SB. Therein is the issue. Right here, I return the address of this attribute. Because I have the address, we can then modify it, which is precisely what happened in the example that I showed, the string versus string buffer. Even if we just have an accessor method with a string buffer because it's mutable, this part over here, that LOLZ here, is we set both this, apparently tried to set the string and string buffer to some corrupted invalid value. The string didn't change because we were just copying, creating a new string. But the string buffer, it was mutable. We go back to this example here. And the original data was corrupted. So when we have, oh, it's stamped on here by Zoom, so I can't move it anymore. When we have a reference to something, even with just a mutator, because we have the address of that attribute, potentially, then there's issues with the proper approach with information hiding. Potentially, you can still set that attribute to an invalid value. And what he's getting at right here is what I talked about previously, at least the concept, is when we have a accessor, rather than returning the address of the actual object, we create a new object. And I'll do that with a code example coming up. And he's illustrating how it works. But the code example, I think, because you can see the output, see the effects of it. Any questions so far? No? Okay, so get rid of the, oh, clear all these drawings. There we go. So with this example, I had to make a few classes defined here to be able to illustrate my point. We've got class person. It has as an attribute a reference to another class, dog. This dog is mutable. We can actually change. Now, the definition, why mutable, there's some people that define how to create a mutable class in Java. What you'd have to do is set all attributes to private, not have any mutator methods. But a final thing is add this keyword right here, final. The keyword final at this point this is part of making it immutable. Means you can't extend it. So you not only have to make all attributes private, not have any mutators. That means the only time that we can set it is through the constructor. So we set it, thereafter we can't change it, and we can't make any child classes. That's actually what people describe as having a mutable class. So this doesn't fulfill any of the requirements. Furthermore, its attributes can be changed. Attribute, at least the name attribute. This is an immutable type here, but we could have it point to a different string. So in a sense, we could corrupt the name field. I have two copies where I'm copying an object of type dog. There's a regular copy. Copy this dot age. Oh, no, this is a good copy here. I'm looking at this. And I'll explain how this one works. This is a safer one here. I have a set here, which can set age. And then I have a toString. What this is going to do is this takes, when we call copy, it's going to take a parameter of another dog. This one here, person. Oh, we use it here, so I'll wait until I get this trace here. It's going through this. I'll defer explaining what this one does until a moment here. I want to get into class person. Class person has as an attribute a dog. That's your best friend. Person's best friend is a dog. Just an example. My bestie. So when I create a person, we actually have to have a dog to indicate who is this person's best friend. And yes, I could check for null here, but let's try to fit this in the screen. There's two ways that I have accessors, no mutators in this one, but two ways that I can access that attribute. And I named it aptly. One is get actual dog. So what I do is I return best friend, what's stored in it, but that's the address. This method returns address of the attribute best friend. As I say, this one's risky. We'll see why in a moment. This one's safer. We look at the risky one first. Oh, I think I'll use the Acrobat's annotations because it doesn't stay at that location. So if we have the risky approach here, something set to 77 here. So I get actual dog, that's the reference. Sorry, we have a person and we have a dog here. We create a dog. As we create the person, we pass D1 to it, indicating that D1 is P's best friend. Because we look at the constructor right here. As we construct a person, we have to have the dog to set the best friend attribute. Now we skip this one over here. Let's go over here. Just be aware that I have set the attribute of the age of the dog, D2, to 77. So we do get a 77 here. Now, over here, get actual dog, D2 is a reference to a dog. It contains some other address here. But now, P2, we call get actual dog, it returns the address of best friend. So we have the address here. I'm going to use Zoom's annotation, I think, but it's a little bit better. No, not Zoom's, Acrobat's. Text. I'll show you where I'm pointing at in a moment here. Get actual dog is this one. It returns the address. Make it a little smaller. So I've got more room to type in. Oh. Get actual dog. We have an attribute line best friend, and this returns the address of this attribute. Because we have the address, this set age now, both of these ones get set. We have this D1 and D2, dog 1, dog 2. We create one dog, the age is 7. We're trying to have a second dog here, D2. And if it was two dog objects, one would be change, one wouldn't. Both of them are changed. We've actually corrupted that attribute. Both are changed, and there are no, notice here, no mutators, only an accessor. The code on the right-hand side only has accessors. We actually changed the attribute. And we changed it because we had the address of the best friend attribute. So this one, we used to get actual dog, and that's dangerous because it returned the address of the my best friend object. Over here, the safer approach. So we create a dog. Age is 7, name is Benny. So I have little Monsieur Benny. We have a toString. That's how we, whoops, where's that toString here? We have a toString for the dog. So it displays the age and the name here and returns that string. That's how we're able to display these values here. Now we create a person, as we saw before. This dog we created is the best friend of this person. Now, we have another reference to a dog. We use this person object to get a copy of, as the name implies, not the actual dog attribute. Let's look at get a copy of a dog now. Get a copy of a dog. We create a new dog object and put the address here. Move the zoom toolbar away because I don't want to accidentally annotate. It's not as good as the, shoot, it's not letting me move it all the way. Oh, wait, I'm getting kind of confused. Here's this. We create a new dog object here, right there. And this contains the address of the dog object. And here, that review we had the stack and the heap is timely here because we create this new object on the heap. And then we return the address of the object. And on the stack, it's a stack because it's a local. A copy contains the address of this new dog object, which is separate from this. This is a different dog object that we passed in here. Now, what we want to do is, I didn't talk about this copy over here, but I will now. We pass the address of this new dog object to copy. The copy now, the new dog created is passed here. Get copy of dog is passed in. To copy. There. And whose copy method did we call? What is it, this reference? It's best friend. It's the attribute of person. So we're going to dog copy is going to be this new dog that we created, I said. And best friend is the attribute of person. So best friend, refer to this here, it refers to best friend. We take the attributes of the best friend and copy it into the new dog. That's the effect. So right here, what we are going to do there we go. Copy the attributes. I haven't finished annotating it yet. Right here, and right, and right. There. The best friend field into the temporary dog. Into the temp dog. So this dog we created here, what we're going to do is copy the attributes of this best friend dog into that dog. So now what's the effect? All the information about best friend is stored here. And we return the copy, the address of the copy we created here. And return it. Right there. So who called get copy of dog? Right here. So D2 is going to contain the address of the temporary dog we created, not the actual dog attribute. Oops, we're in annotate mode still. So consequently, we have a separate dog here. The separate dog, we set the age of 77. The original dog's age is 7. So we've protected the data. To prove that we have two dog objects and not just one like we have here, we display, using these references, the two dog objects. One is still 77. That's the one that we created right here. But the other, one is still 7, but it's the other one, the copy, that we set to 77. And the difference between this and this is This one gets the actual dog right here. This one returned the address of the temporary dog that I created. So let me get rid of this stuff. They're all drawings. There we go. So if you have the recap is, if we have an attribute that is a reference to a variable type, having just a regular accessor is dangerous because we have the address of that variable type. On the other hand, to protect it, what we can do is create a new object, not this object, but a new object, copy the data from this one into this temporary one and return the address of the temporary one. So we can see the data, but not change the original data. It's kind of like being able to pull a credit bureau on someone. If I have a credit record, credit bureau, and I'm applying for a loan or new credit card, someone wants to check my credit record. So they get a copy of my credit bureau, not the actual one. So they can't corrupt my actual credit bureau. This is exactly the same. This is a metaphor for that approach. And the bottom line is, if you have a variable attribute, even regular accessors, a variable attribute that's a reference, regular accessors won't necessarily protect it. We make a copy of that attribute and then return the address to the copy.